Hello friends, welcome to this video. In one of our earlier videos of motion, we solved some questions related to motion. You can see, okay, these questions we solved up to question number 5. So today we are going to solve question number 6, which is a graph here you can see, and I will explain how to solve such questions, graphical questions. Okay, let us read the question first, and then I will explain the solution. The figure below represents the speed-time graph for a particle. Find the distance covered by the particle between time t equal to 20 minutes and time t equal to 40 minutes. Okay. So in this graph, you see speed is plotted along the y-axis and time is plotted along the x-axis. Okay. So between time t 20 minutes and 40 minutes, how much distance has been covered by the particle? Okay. So first look at the graph very carefully. What informations do we have here? We have to calculate the distance covered by the particle. So in order to calculate distance, we need two very important things we need. One is speed. So distance is equal to speed multiplied by time. Okay. So speed is along the y-axis, time is along the x-axis. So speed, you see the plot for speed, okay, this is a straight line, the blue line you can see, this is a straight line, and this has not changed, okay, this has not changed during the course of motion of the particle. So speed is fixed at 10 kilometers, okay, 10 kilometer per hour. And time. Okay, time is here between time t 20 minutes and 40 minutes. Okay, this is time 20 minutes and this is time 40 minutes. So how much time has elapsed? So time elapsed is 40 minus 20 equal to 20 minutes. Okay. So it's now very simple. If you multiply these two terms, you can calculate the distance covered by the particle. So 10 kilometer per hour, the speed of the object, which is constant throughout, multiplied by 20 minutes. 20 minutes means 20 divided by 60. This way we can convert minute into hour. Okay. So how we can calculate this now? It has become so simple. So R gets cancelled. So 0 get cancelled and it will be 3. Okay. So it will be 10 by 3 kilometer. So in this given time, t 20 minutes and t 40 minutes. So the distance covered by the object is 10 by 3 kilometers. Okay. So I hope you have understood the solution of this particular problem. So yeah, once again, in order to solve this question, you need to know about the speed and you need to know about the time. Once you have got information of both these quantities, we can solve such a graphical problem. Now I'm going to, I have you pause the video for a while and you'll see how we have solved, because I'm going to clear all the drawings now and I will move to the next question. Okay. Okay, friends, you can see another problem here, another graphical problem here. So find the from the following this figure shows a speed time graph. Okay, speed is along the y-axis, time is along the x-axis. Find the distance traveled in the time interval 0 to 30 seconds. Okay, 0 to 30 seconds. So in 0 to 30 seconds time, how much distance has been covered by the particle? So again, here two things. So distance is equal to speed multiplied by time. Okay. So, but here one more concept is involved. Distance can also be calculated by calculating the area of this portion. Okay, area which this graph encloses with the x-axis. Okay, so distance, so I'd rather write it like this: distance is equal to area enclosed by the plot with the x-axis. Okay, the x-axis is here and this is the plot. So this area, once you can calculate it, you can calculate the distance covered by the particle. Okay, so let us do the calculation. So again, speed, you see speed is constant. Speed is constant at 15 meters per second. Okay, so how we can calculate this? So for simplification, let us divide this area into 3 portions. Okay, I am drawing straight lines up to 5, up to 25. Okay, so now you see this has become very easy. So we have one triangle, and here we have one rectangle, and here we have another triangle. So how to calculate the area now? Because once you can calculate the area, that would give us the distance covered. Okay, so first calculate the area of this triangle, the first triangle. So there are 3 regions: region 1, region 2, and region 3. Area of the first triangle is half multiplied by base. Base is 5 multiplied by height. Okay, base height, half base height. Base is 5, height is 15 minus 15. Okay, 15 meter per second is the speed, maximum speed. So 15 minus 0, that would be 15. So it would be meter. Okay, because 5 second and meter per second, so second would get cancelled, the area would be like this. Okay, so half into 5 into 15, so it will be 75 by 2 meters. Okay, that is the area of the first triangle. Okay, so second region, you see the second region now. The second region is a parallelogram. Okay, you can see it's a parallelogram. So what is the area of the parallelogram? Area of the second region is 5 at 25. So it will be 25 minus 5. So length is 20, and here it is 15 minus 0. That would be 15 again. Okay, so it would give us how much? 300 meters. Okay, so next is this third area. So what is this area? So the calculation of this area is same as before, same as the area 1. So we can directly write it as 75 divided by 2. Okay, this 75 by 2 would give us the area. Area means the distance covered by this particle between time 25 seconds to time 30 seconds. So 75 by 2, it was in previous case, meter. So now if you add up all these 3 distances, okay, so you can actually calculate how much distance the object has covered between times t equal to 0 and 30 seconds. Okay, so let us calculate this. So total area is 75 by 2 plus 300 plus 75 by 2 meter. Okay, so 300 plus 75 plus 75, this would give us how much? That would give us simply 75. 75 by 2 plus 75 by 2. This will simply give us 75. Okay, so total area is 375 meters. So total area is 375. Okay, sorry, total area is this much. Area is not meter actually, but total area gives us the distance. Okay, so the distance is 375 meters. So I hope you have understood the calculation. Once again, the concept that you have to apply for this particular question is you need to calculate the area enclosed by the plot, okay, with the x-axis. Okay, once you can calculate the area, that is the distance traveled by the particle from time t equal to 0 second to time t equal to 30 seconds. Okay, so 375 meter is the total distance. So I suggest you to pause the video for a while and understand this solution, because I am now going to clear all the drawings. Okay, so we have another question, which is a little bit conceptual question. So let us go through this question. Consider the following velocity time plot. Okay, so this is a velocity along the y-axis, time along the x-axis plot. So there are some questions. So what are the questions? Let me read the questions and then we'll solve. Does the particle move along the positive x direction at time t equal to 0? What is the time t equal to 0 here? Okay, here. So this is 0. So time t equal to 0 is here. So at time t equal to 0, does the particle move along the positive x-axis? The answer is no. Because you see, up to time t equal to 5 seconds, the particle travels in the negative x-axis. Okay. So the answer is simply no, because the particle is in the negative x-axis. Okay, so negative. So this portion is negative, the velocity is negative, so it does not move in the positive x direction. Okay, it moves along the negative x direction because the velocity value is negative. Okay, at time t equal to 0 second. Does it come to rest? If so, when? Okay, the particle, does the particle come to rest? How can we determine from this graph? Very easy, the particle comes to at rest here, because at rest means the velocity of the particle has to be 0. The velocity has to be 0, so draw a straight line. Yeah, 0. At time t equal to 5 seconds, the particle comes to rest, and that you can calculate, or that you can understand from the graph. Okay. So does it turn around? If so, when? Okay, does the particle turn around? Turn around means if it was traveling along the negative x-axis, and if turns around and it starts moving along the positive x-axis. So the answer is yes, where at time t equal to 5 seconds. Okay, at the same point as before, at time t equal to 5 seconds, or rather I can write it here. At time t equal to 5 seconds, the particle turns around. Okay, because it was moving along the negative x-axis. Now it starts to move along the positive x-axis. Okay, so these are the answers. Okay, so I hope you have to always check this velocity time plot very carefully. So it moves along the positive x direction? No, because at time t equal to 0, it moves along the negative x direction. Velocity value is negative. Does it come to rest? Yes, it comes to rest at time t equal to 5 seconds. And does it turn around? Yes, it again turns around, because here at this time t equal to 5 seconds, the particle moves its transition from negative x-axis to positive x-axis. Okay. So I hope you have understood all the 3 graphical problems that we have discussed so far. I'm going to remove the annotation, so pause the video for a while and watch the solution. So yes, so I hope you have understood here. So just calculate the area in this particular question to find the distance traveled. And here also just calculate the area between time t equal to 20 and time 40 seconds, and also the distance covered is speed multiplied by time. Okay, so that is how you can calculate. So I hope all these graphical solutions have been useful to you. If you have liked the video, please like it, share it, subscribe to the channel, and thank you very much for watching. We will meet in the next video. So thank you very much.